Karl Fischer titration is a classic titration method in analytical chemistry that uses coulometric or volumetric titration to determine trace amounts of water in a sample. It was invented in 1935 by the German chemist Karl Fischer. Coulometric titration: the main compartment of the titration cell contains the anode solution plus the analyte. The anode solution consists of an alcohol, a base, SO2 and I2. A typical alcohol that may be used is methanol or diethylene glycol monoethyl ether, and a common base is imidazole. The titration cell also consists of a smaller compartment with a cathode immersed in the anode solution of the main compartment. The two compartments are separated by an ion-permeable membrane. The point anode generates I2 when current is provided through the electric circuit. The net reaction as shown below is oxidation of SO2 by I2. 1 mole of I2 is consumed for each mole of H2O. In other words, 2 moles of electrons are consumed per mole of water. Bar I2 plus bar SO2 plus B plus H2O A2 BH plus E plus BSO3, BSO3 plus Rho BH plus ROSO3. The endpoint is detected most commonly by a bipotentiometric method. A second pair of PT electrodes are immersed in the anode solution. The detector circuit maintains a constant current between the two detector electrodes during titration. Prior to the equivalence point, the solution contains I but little I2. At the equivalence point, excess I2 appears and an abrupt voltage drop marks the endpoint. The amount of current needed to generate I2 and reach the endpoint can then be used to calculate the amount of water in the original sample. Volumetric titration: the volumetric titration is based on the same principles as the coulometric titration except that the anode solution above now is used as the titrant solution. The titrant consists of an alcohol, base, SO2 and a known concentration of I2. 1 mole of I2 is consumed for each mole of H2O. The titration reaction proceeds as above, and the endpoint may be detected by a bipotentiometric method as described above. Advantage of analysis: the popularity of the Karl Fischer titration is due in large part to several practical advantages that it holds over other methods of moisture determination, including high accuracy and precision, typically within 1% of available water, for example 3.00% appears as 2.97 to 3.03%. Selectivity for water: small sample quantities required, easy sample preparation, short analysis duration, nearly unlimited measuring range, suitability for analyzing solids, liquids, gases. Independence of presence of other volatiles, suitability for automation, linearity, single-point calibration, no calibration curves necessary. In contrast, loss on drying will detect the loss of any volatile substance. The major disadvantage is that the water has to be accessible and easily brought into methanol solution. Many common substances, especially foods such as chocolate, release water slowly and with difficulty, and require additional efforts to reliably bring the total water content into contact with the Karl Fischer reagents. References: Fischer, Karl. Verfahren zur Maueranalytischen Bestimmung des Wassergehalts von Flur 1/4 unfessen K Paragraphe PERN. Anjou. Chem 48, 394 Euro 396 doi, 10.1002/Ange 19,350,482,605. Literature: Water Determination by Karl Fischer, Titration by Peter A. Bruttel, Regina Schlink, Metrum AG. See also, Titration, Moisture Analysis. References. External links: EMD Chemicals Aquastar Tech Notes.